Welcome to an essential dive into cybersecurity, understanding SQL injection. This critical web vulnerability allows attackers to interfere with how applications interact with their databases. SQL, or structured query language, is the backbone for communicating with website databases. It's how applications request, update, and manage data. Imagine a website login form. When you enter your username and password, the application constructs an SQL query to verify your credentials against its database. SQL injection exploits vulnerabilities where user input is not properly sanitized or validated. Attackers insert malicious SQL code into input fields, like a login form or search bar. This malicious code is then executed by the database, allowing attackers to bypass security, access sensitive data, or even modify database contents. For instance, an attacker might enter or 1 equals 1 into a username field. This manipulates the query to always return true, effectively bypassing authentication. The impact of a successful SQL injection attack can be severe, leading to unauthorized access to sensitive data like passwords and credit card details. It can also result in data modification or deletion, compromising system integrity and causing significant financial losses and reputation damage for organizations. SQL injection attacks are broadly categorized into 3 main types: in-band, inferential, and out-of-band. In-band SQLi is the most common, where attackers use the same channel to attack and gather results. This includes error-based and union-based SQLi. Inferential, or blind SQLi, means attackers can't see direct results. They infer information based on the application's responses, using Boolean-based or time-based techniques. Out-of-band SQLi is less common, using a different communication channel for attack and results, depending on specific database server features. Preventing SQL injection requires a multi-layered approach, combining secure coding practices, input validation, and robust database security measures. One of the most effective techniques is using parameterized queries, also known as prepared statements. This separates SQL code from user data. This ensures that user input is treated as data, not as executable code, preventing malicious injections from being run by the database. Input validation and sanitization are also crucial. Developers must validate user input to ensure it conforms to expected data types and formats. Sanitizing input by escaping or removing potentially harmful characters is vital to neutralize malicious SQL code before it reaches the database. Other key prevention techniques include granting database accounts the principle of least privilege, using web application firewalls, and conducting regular security audits. Keeping all software components updated and disabling verbose error messages that could reveal database structure are also essential steps. By implementing these comprehensive prevention techniques, developers can significantly reduce the risk of SQL injection attacks and protect their web applications and databases from malicious actors.